Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. We present you our research result titled Design of Temperature and Humidity Control System on Oyster Mushroom Plant House based on Internet of Things. This presentation is presented in the ICBB 2020. We are from Agriculture Engineering, University of Mataram. First is introduction. Oyster mushrooms are generally cultivated in kumbung covered by black color material. The optimum conditions for oyster mushroom growth is 24 to 28 degrees Celsius and 80 to 90% humidity. However, during the dry seasons, the failure rate of mushroom cultivation is increasing due to the high temperature inside the kumbung. Therefore, the control systems based on Internet of Things need to be applied in the kumbung. The methodology of our experiments is we conduct experimental methods by designing control systems and test the performance of the control systems that consist of Arduino Wemos D1s and DHT11 sensors that connected to humidifiers and nozzles. We apply these control systems to monitor and control temperatures and humidity inside the prototype of plant house of mushroom. The control system mechanisms is shown by these flow diagrams. The sensors first will read the temperatures and the humidity inside the oyster's kumbung, and then if the temperatures is above 28 degrees C and the relative humidity is below 85%, the nozzle and humidifier will be activated by the system. If not, the nozzles and the humidifier will be deactivated by the systems. This shows you the DHT calibrations for temperatures and for relative humidity. We use warm waters and cold waters for the temperatures. As we could see in here, the R squares is very high, almost 1. This shows that the accuracy of the sensor is very high. For the humidity, even though it's not near 1, but this R square is relatively high. Therefore, the data is generally valid. As we could see in this slide, this shows you the temperatures and relative humidity inside the mushroom plant house. This is using control system. This is not using the control systems. In this control systems, we could see that the relative humidity could be maintained in the optimum conditions for the mushroom, while for without control systems, we can see that relatively the humidity is below the optimum conditions. So we could see that the control system successfully can maintain the humidity inside the plant house of mushrooms, while for the temperature is very fluctuative in here, depend on the temperature outside the plant house. This is the mushroom yield. We could see that in the kumbung with control systems, the conditions of the produced mushrooms is brighter in colors, while in the without control systems, the mushrooms show yellowish color. However, as we could see in this slide, The mushrooms yields for the control systems show us that the amounts of mushrooms is higher than the amount of mushrooms without the control systems, but for the average surface area is less than the without control systems. We also designed that the control system could be monitored remotely using Blink applications, and this slide show you that the Blink application could work properly and connected to the control systems. The control systems inform to the Blink applications, and the Blink applications show us the temperatures and the humidity inside the plant house. Finally, the conclusions. First, the control systems could work successfully to maintain temperature and humidity inside the plant house of oyster mushroom. Second, the HC11 sensor has high accuracy to measure temperature and humidity. The third, more amount of mushrooms with less surface area were obtained in the kumbung with control systems. And the last one is the control systems performance could be remotely observed using Blink applications. That's all of our presentations. Thank you for the kind attention. Hopefully this technology could be applied in the society and give beneficials to others with further improvement. That's all. Assalamualaikum warahmatullahi wabarakatuh and good morning.